All right, moving on. Usually, after fracture repair, the bone is immobilized to promote bone healing. This is a form of external fixation. There are a variety of materials that can be used to achieve this task. Overall, the usage of casting material has inherent risks for the patient. Read through the considerations on this slide carefully. And when you're done doing that, do some independent research on the pros and cons of fiberglass casting material and plaster casting material. There's plenty of information out there for you to find. Finally, also make sure you know the difference between a cast and a splint, as either can be made with fiberglass or plaster. We're going to finish out this lecture by discussing the various instrumentation present in orthopedics. First up is the power equipment, or power tools. You may have seen some of these tools in other specialties that have had anything to do with bone, like ENT, but they ultimately belong in this specialty. I can tell you that when I began as a scrub tech, I didn't know anything about power tools, and now, thanks to Ortho, I can tackle any job with power tools. If you're inexperienced with power tools, take heart. It's not all that bad. The orthopedic drill, as you'll see in your slide, has a few more parts than the typical garage drill. In the picture with the blue background, you'll see a black handpiece here. And I lost my spot. You'll see the black handpiece in the center with the black power cord next to it. The power cord connects to the handpiece and then is plugged into a power source off the field. That is one method of providing power to our power equipment. Surrounding that handpiece are several attachments, each with their own purpose. The Jacobs chuck, which is at the top of the screen, is very important for drill bits. The chuck key, off to the right of the slide, right here, is a paired item with the Jacobs chuck to tighten the drill bit into the chuck. There are a few other attachments, which are kind of hard to see, but they are specialized to accept pins, this one, and specialized drill bits, this one. The final item in this slide shows the low speed drill, right here, which is also connected by the power cord in the blue picture, and it's great for drilling in very small spaces. You'll want to know that power tools can be powered by more than just electrical cords. Some equipment uses compressed nitrogen or even sterile batteries. Again, these tools will be selected based on surgeon's preference, but you will need to know which tools require which power source so that you can be ready. Remember, any power tool that is in use has the potential to get very hot, and it is the scrub's responsibility to keep it cool by drizzling irrigation on it while it's in use. Your next slide discusses the various attachments that go on the drill. Pictured are the examples of reamers and a drill bit. Each attachment serves a different purpose and will therefore likely get used at different points of the same procedure. Burrs use high-speed rotation to polish or remove bone. Drill bits drill holes into bone to accept pins or screws for fixation. Shavers can be attached to oscillate back and forth, which means they don't rotate all the way around, and they shave soft tissue, like bursa in the synovial joints. Chucks are attached to drills and then accept other instruments like drill bits. Remember we talked about that on the last slide? Taps are used when the patient's bone is particularly hard, so think young, healthy bone, to make way for the threaded screw. Reamers are used to enlarge the medullary canal during long bone fractures, which may be otherwise too narrow to allow a nail to pass through it, which is how the fracture is being fixed. We'll definitely cover nail fixation during jigsaw. The two that I skipped over are drill guide and depth gauge. Technically, neither of these items attach to the drill, but they are paired with the drill to guide the bit in the right direction and measure the depth of the drill to determine screw length. Your next slide shows a pretty gold saw, which is specifically a battery-powered saw, because the base is designed to accept a sterile battery. This slide is meant for you to know the different types of saw cuts made and their definitions. A reciprocating saw moves in and out. It's great for when surgeons want to make precise cuts because they can go straight at the targeted area and saw out exactly what they want to. A sagittal saw is inserted into the saw at a right angle to the handpiece and moves from side to side. That can be helpful during hand surgery because the working space is small, and by keeping it at a right angle, less force is exerted on the saw itself, which in turn makes precise cuts and reduces injury risk. The final type is the oscillating saw, which is great during total joints because you're making big cuts into big bones. An oscillating saw is fixed along the same plane as the handpiece and moves back and forth. The image on your slide is specifically an oscillating saw handpiece. Using your new saw blade knowledge, draw the blade coming out of the saw to keep it accurate with the description of an oscillating saw. Your next slide covers hand instruments and measuring devices. The three hand instruments are a lane, spelled L-A-N-E, bone clamp, which is particularly helpful to hold a fracture together and hold a plate in place over a fracture. Next is the curved coker, or Ochsner, which is great for grabbing comminuted bone fragments and putting them back in their anatomical position. And lastly is the Lewin bone clamp. Lewin is spelled L-E-W-I-N, and it also is a bone clamp and gets used on the patella. The measuring devices on this next slide help surgeons measure angles of rotation, diameter of the ball portion of the humerus and femur, depth gauge for measuring drilled depth to determine screw length, and bone screw ruler, which allows you to verify screw lengths on the sterile field, right here. The next few slides show you periosteal elevators in varying sizes. Do you remember what the periosteum does and what we need to do to it? Write it down here, because again, the more you write it down, the more you talk about it, study it, the better it will be for your brain. Following that slide is a picture of a bone cutter, here, bone cutter, and a bone rongeur. Bone cutters are for just that, cutting bone like in an amputation. Bone rongeurs are for biting and contouring bone and fibrous tissue. Both instruments need to be cleaned by the scrub while in use to ensure that the biting tips can do what they're intended for. The next slide shows you osteotomes, which are paired with a mallet and are used to create slivers of bone or excise slivers of bone, and those slivers are occasionally used as bone graft. Be in the habit of saving all bone that you receive from the tips of instruments and ask if it needs to be saved or not. You will eventually get the hang of it, but until then, keep the bone for bone graft, because once it's off the field, there's no coming back. Your next slide shows a rack of curettes, and I'm sorry that it's so blurry, but I picked this picture to show you there's a variety of sizes, and know that each curette is a different size, and they can be used to carve out cysts or infection, or to collect cancellous bone for bone grafting. We'll pause here.